All right, so today we're going to talk about how to multiply polynomials. Yesterday we talked about addition. Addition is going to come back
You
in a
mean
little
Friday?
bit. Yes, I mean Friday. Thank you. So let's talk about multiplication. Multiplication is quite a bit easier than addition. If you'll recall from addition last Friday, we said that you could only add two of these terms together if they had the same base and the same exponent. So for example, you could add x squareds together, but you could not add x squared and x, right? Multiplication, anything goes. You can multiply any two things together. They do not have to be the same degree. They do not have to be the same variable or the same base. What you have to make sure of when you multiply is that whatever you have outside the parentheses, which in this problem is a negative 3x squared, gets multiplied by every single thing inside the parentheses. That is distributive property. Very good. So first thing I'm going to do is negative 3x squared times 7x squared. Then I'm going to do negative 3x squared times negative x. And finally, I'm going to do negative 3x squared times 4. You'll notice that I put plus signs in between all of this multiplication. We're going to do that every time. We're just going to add up whatever the results of our multiplication is every single time. We have talked a little bit, actually we've talked a lot about how to multiply these terms together. If I have a negative 3x squared and a 7x squared and I'm multiplying them, what's the first thing I multiply together? Even before then, even before I deal with the exponents. The coefficients, exactly right, which in this problem are? Negative 3 and 7. Negative 3 times 7 is? There we go. Now I can multiply the x's together. I've got an x squared and an x squared that I'm multiplying. X squared and x squared multiplied together give me x to the, very good, x to the 4th power. Good. Plus. Okay, now let's multiply the green ones together. Negative 3x squared times negative x. It's a good guess, but when I don't have a number in front of the x, like I do here, what number do I use? 1. There's a hidden 1 right there. That's negative 1x. So I have negative 3 times negative 1, which is a positive 3. And then I have x squared times x, which is x to the 3rd power. Plus negative 3x squared times 4. Good, negative 12. X to the, very good, x to the 2nd. And that is my answer. Is there anything in this answer that I can combine? Can I combine the negatives? Do I have anything that has the same base and the same degree? No. Now on the end, I had a plus negative 12x squared, but when I wrote my answer, I wrote it as just minus 12x squared. Is that okay?
Yes.
Sure, plus negative is the same thing as minus. That's fine. So the most difficult thing about multiplying these polynomials, assuming you remember our lesson on combining the variables with exponents from a couple of weeks ago, the most difficult thing is making sure that you get everything multiplied by everything else. So let me show you this exact same problem, but I want to show you a method that maybe will keep you a little more organized. I'm going to make a little table here that has 3 boxes. And inside those 3 boxes, I'm going to put my negative 3x squared. Oops, sorry, not negative 3x squared. That was on the outside. I'm going to put my 7x squared. I'm looking in the parentheses. the minus x and the positive 4, and then out in front, I'm going to put the negative 3x squared. This is the exact same thing as the distributive property, just might be a little easier for you to keep them organized. Make sure that you get everything multiplied by everything else. So the first thing that I would do is multiply negative 3x squared times 7x squared, which we already figured out was negative 21x to the 4th. Just write that right up there. Negative 3x squared times negative x is positive 3x squared. And negative 3x squared times 4 is negative 12x squared. And then there's my answer right along the top of the table. Yes, ma'am?
There's 2 3s up at the top instead of 2s.
Huh?
It's just on the top or underneath the blue green.
3x squared should be a 3x.
Oh, I wrote the wrong exponent. Thank you. Some people, when they write this out, these science nerds like to write it as though it is a Punnett square. They put the negative 3x squared out in front, and then they put the problem along the top. And inside the squares, they put the result of multiplication, just like you. It's sort of like a math Punnett square, I guess. I don't care which way you use to organize these. I will say that using this box method is going to be a little bit easier tomorrow when instead of doing a monomial times a polynomial, we do a poly times a poly. That gets a little complicated and you may want to use the box.
Wait, what are we doing tomorrow?
Polynomial times polynomial.
Oh, okay.
Your box will get much larger. Instead of doing negative 3x squared times all that stuff, you'll do like negative 3x squared plus 2x plus 7 times all that stuff. Yes, is the appropriate answer. Oops. Okay, so let me give you a couple to practice here. I don't care which method you use. Dealer's choice. You can either just do the distributive property, which is what the pros do, or you can write out the box, which is a really great way to make sure you don't miss anything. Should take back some of the bad things I've been saying about y'all behind your back on the internet. I mean, I'm not going to, but I should. Okay, let's see. Christian, what's the answer to the first one? Mm-hmm.
Plus 10a to the 3rd.
Mm-hmm.
Minus 35a to the 2nd.
Mm-hmm.
Is that right?
That's right. You nailed it.
Mr. Taylor,
Yes, sir.
head over to Miss Parker's.
Okay, bon voyage.
Yeah.
And Abigail,
I didn't do them.
what's the answer to the first one?
I have no idea.
Really? Because I just wrote that. Christian just said it out loud.
Oh. Stop.
Okay. What's the answer to the second one?
Don't do that one either.
Why didn't you do either one of them?
Because I'm doing Friday's notes.
Or do you want to see me cry? Is that what you want?
And then when you send me those ones, I'm going to
Do
do those.
you want to see me cry?
A little bit, yeah.
A little bit. Harley, you are the lifeline. What is the answer to the second question? Did you say d to the 7th? Did you say d to the 7th power? Because you added the exponents? Good. D to the 7th, good. And then? Very good. Fourth power, very good. There's a hidden 1 right there on the D. Good. And then? Very good. Nailed it. Perfect answer. I can tell by the quality of your answer that your math teacher is incredibly inspirational and handsome. We're feeling good about those? Okay. Let's try.
How
What?
would you write those in the box?
Oh, good question. So Catherine asked the same thing. The first one, depending on how you drew the box, you would have the 5a squared outside, and then you could put them across the top, like that. This one, though, because there were 4 terms inside the parentheses, we would have to make a box that was a little bit longer. And we put the negative 6d cubed on the outside, and either across the top or inside the boxes, whichever you prefer. Absolutely. I should have been more specific when I taught you that. Yes, you can add boxes if you need to. And we're going to have to tomorrow, because tomorrow we're going to do some pretty gigantic problems. So you can make it as big as you want to.
Okay.
So all these problems that we just did, all 3 of them, you multiplied and then you were done. Let me show you what it looks like when you multiply and then you're not quite done yet. Are we still what? No. I mean, yes, you're always practicing. But we're not going to I'm going to show you how to do this one, and then I'll give you a couple to do on your own. And then I will give you 47 homework problems.
37?
No. That'd be ridiculous. 47.
47?
Yeah. I mean, if you only know how to do 46, it could just be a lucky guess. So you got to do 47 so I can make sure you know what you're doing.
Wait, you want us like that question? Or please?
No.
Zeke, have I ever given you 47 problems? I'm
You
clearly
gave us 34.
not on a homework.
Yeah.
Yeah.
That sounds outrageous. Kind of a monster would do that. So this one, oh right, me. So this one has 2 distributive properties. We've got one distributive property right here with the 2p, and then we've got another one down here with the negative 5. So I'm going to do 2 distributive properties one at a time. So negative 2p times negative 4p squared is?
And then negative 8.
No? Did I say negative?
Yes.
Well, I wrote positive, which is what I meant.
And then that would be 10p
Very good, except for the
plus 10p.
end of your sentence. Plus 10p squared, because p times p is p squared.
And then
Minus.
Okay, so first distributive property done. Now I'm going to move on to the second one. Okay, thank you.
Negative 10p.
Good.
Second power.
Negative 10p to the second power.
and then negative negative 100.
100. Now, can you explain to me why I'm not done with the problem right now?
Because you have to solve it.
Yes, ma'am.
Because you have a positive 10p.
Right, I've got 2 things, 2 p's that are both raised to the same power, which means I can do what with them? I can combine them. What is positive 10p squared minus 10p squared?
0.
0.
So it'll be p squared.
No, it'll be 0. And that's what I'm left with. And that is the answer.
Oh, these are fun.
They're fun.
Yeah.
What happened
They're
to
kind of confusing.
They're fun.
What happened to the p
the
squared?
p got rejected?
We had a 10p squared, and we had a minus 10p squared. Those went away. 10 minus 10 is 0. No more p squareds.
Did you get your chair decorated?
So what you have to pay attention to is,
Sorry.
what you have to pay attention to is, when you finish multiplying them, is there anything that you can combine? So let me give you a couple of those to try. And then I'll give you your 47 homework problems. Yes?
You should stop.
I should stop what?
You track
What should I stop doing?
Never mind.
You're about to say you should stop being awesome. I'm afraid it's impossible. I can bring it back to 90%. That's the best I can do.
Hmm.
Oh,
Let me give you a couple of these to try on your own. What?
It doesn't look overwhelming. It looks confusing, but it looks.
Excuse me, everybody. I got to take this very important phone call. Good morning. Yes. No problem. Mm-hmm. Elijah, they need you in the front office. They said, and I quote, "How dare you try to sneak into class without getting a tardy slip." Whew. Those look overwhelming.
Okay.
So I know we're still working on the second one, but let's take a look at the first one. So this would be 15x squared, and then 6x, oops, and then minus 12. I saw mostly correct answers on that one. The next one's where we kind of fell apart. Because when you multiply a negative x times a 7x squared, that's going to give me x cubed. And x times x squared is x cubed. So minus 7x cubed. Then minus 2x squared. And then plus 3x. And now we do what we did on Friday, which is, do we have anything we can combine?
The X
So we
cubed.
start with the biggest exponent, which is x cubed. Is there anything else in the problem that is x cubed?
Yes. No.
No.
It's. I'm tired. It's.
Okay, then we look at the next biggest, x squared. Do we have anything else that's x
Yes.
squared?
2x
Yes.
squared.
2x squared. What's 15x squared minus 2x squared?
13.
Positive
X squared.
13x
Positive, yeah.
to the second power.
Yep, positive 13x squared.
Doesn't matter how you write it,
What do you mean?
like how you put it, like how you wrote it.
In order.
Do you have
Yes, it needs to go from biggest exponent to smallest.
Why?
Do we have anything else? Just because that's the way all your answers are going to look on the big bad standardized test. It's good math practice. That's how the pros do it, from biggest exponent to smallest. It's not incorrect to do it in different order. It's just weird.
Ooh, and then you subtract those would be 3x.
Yep, with the 3x for a total of
3x.
Huh?
Wouldn't it be 3x because you subtract
6x plus 3x,
Oh.
9x.
9x, and then our poor little minus 12 who didn't have any friends.
It's okay, 12.
It's okay, 12.
I'll be your friend.
So there's my answer. There's nothing else for me to combine.
I'm not rewriting it. I've already have it written down. Okay, there we go.
I know you still need a few minutes to practice the second one, but I want to at least get you started right at the beginning. When I do the distributive property, I will do 15t times 10y cubed t to the fifth. And I just want to do this first one with you because it has been like 5 days since we've multiplied something with multiple variables. So first we do the 15 times 10. Then we do the t multiplied by t to the fifth, which is t to the sixth. And then the y cubed doesn't have any y's outside the parentheses to multiply by, so it just stays y cubed, and that's the first one. And then we'll
Why
do
is it not
plus.
150y to the third?
Oh, I could do it like that. 150 y to the third, t to the sixth. It's multiplication, so the order doesn't matter, but that's totally fine. Put the y to the third first. So 5 times 15 is 75. And then the question was, okay, I'm distributing the t now. T right here on the outside, and t right here gives me t squared. What about y squared? Well, nothing to multiply him by. He's just plain old y squared. Poor dude.
And you can't.
Then we move on to the second set here. Negative 2y times that. So it's negative 2, because there's no number to multiply by. And then I've got y times y, which is y squared. And then we've got this t squared who doesn't have anything to multiply by, so he just stays t squared.
-2 times 4 would be -8.
Very good.
And
Negative 2 times 4 is negative 8.
Y cubed.
Y cubed. There's no t's in that one at all. So we're done, right, everybody?
No.
No, why not?
Because you have to add all the squared and cubes together.
I gotta see if there's anything I can combine, and there's only one pair of things I can combine. That is t squared y squared, and that is t squared y squared. Those are the only two things that can combine. Nothing else has the same degree with the same variables. So the 150 t to the 6th y cubed stays put, and on the end the minus 8y cubed stays put. But in the middle, when I combine minus 70 or plus 75 and minus 2, what do I get?
-73.
I like 73. I
72.
don't like minus.
Oh, wait, no.
Plus
It's a positive 73.
Y.
And I can do t squared y squared, or I can do y squared t squared. The order does not matter. And that is the answer. Does anyone have any questions? Yes. Correct. The only time exponents change is when you are multiplying or dividing. Anybody else?